विद्यापीठ महिन्यापर्यंत घेण्यात येते आणि
तुमचे कोणी येले का आवाज तुमचं येईल वेगळंच ते हॅलो 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 नमस्कार साहेब सर
बोला बोला
हा आवाज येतो ना सर
येते
हा चालू करायची का सर
करा आता चालू काय ते पार्टिसिपंट काय रिस्पॉन्स ठीक आहे चालू
हा
करा
होईल सर जवळपास येऊन जॉईन झालेली
ठीक आहे चला चालू
चौधरी सर हॅलो
सर बोला ना सर
हा
सर
चालू करायचं
सुरू करा तुम्ही सुरू करा हो जाधवर सर
हो on this auspicious moment and all the participants, I heartily welcome the all college development committee members, dignitaries, and the honorable principal, Dr. J.K. Kakade sir, vice principal, Professor M. Zogde sir, another vice principal and major, Dr. M.N. Gaikwad sir, and my dear colleagues and the students who have joined for this meeting. Friends, our college constantly organizes the different curricular and co-curricular activities in this college, and the many students are gets the benefit to their career, for their career. And our intention in organizing this event is that the students' knowledge can be enhanced, they get the interest in their corresponding subjects. This is our intention. Again, here we can provide the recent development in science and technology. This is the purpose of organizing this event. Friends, for this event, we have as the president, Honorable Principal Dr. J.K. Kakade sir is as president, and for this meeting we have the chief guest, Honorable Captain Dr. Chaudhary V.A., Dayanand Science College, Latur. He will deliver his talk on the recent advancement in material science and nanotechnology. This title is very helpful for the students in getting the benefit in their future career. I hope this lecture will fulfill the hunger of the students in regarding to the knowledge and information which is useful in their future career. Now I request Honorable Captain, I request the college principal to give its introductory speech. Honorable Principal Sahib.
Hello, good morning to all. Today we are here gathered for special guest lecture which is organized by IQC department and Department of Physics. At the very outset, I would like to thanks and welcome to our today's special guest, Captain Dr. Vijendra Anand Chaudhary sir, who is from Dayanand College, Department of Physics, Dayanand College. On behalf of the institute, on behalf of our college, and on behalf of all physics department and the organizers, I welcome all the participants and guests. Today's topic for the special guest lecture, recent advances in material science and nanotechnology. Friends, we know that material science and nanotechnology is a very recent burning and a very cutting edge areas of recent technology and society. Material science and nanotechnology has experienced incredible advances in recent years, unlocking new capabilities that are revolutionizing key industries such as electronics, healthcare, energy, and environmental sustainability. These advancements are not only enhancing performance and efficacy, but they are also able to address some of the most uh, pressing challenges we face today. At its core, physics focuses on understanding and manipulating materials to optimize their properties for specific applications. Nanotechnology, on the other hand, materials and structures at the atomic and molecular level, opening the door to unpredictable precisions and control. When these sectors intersect, they produce groundbreaking innovations. One such innovation is a graphene, often called the miracle material. This one atom thick carbon structure is incredibly strong, lightweight, and conductive, with the potential to revolutionize industries from energy storage to electronics and healthcare. Similarly, metamaterials with their unique electromagnetic properties are enabling advances in areas such as telecommunication, imaging, and even the development of invisibility clocks. Nanotechnology has also introduced us to carbon nanotubes, which are known for their extraordinary strength and conductivity. They are now being used in everything from advanced batteries to potential medical treatment. Another exciting area is nanophotons, phototones, where researchers are manipulating light at the nanoscale, leading to innovation in solar energy, communications, and medical imaging. In the energy sector, nanotechnology has brought advanced batteries with faster charging times and greater storage capacities. While in healthcare, nanoparticles are being designed for precision drug delivery, providing hope for more effective treatments with fewer side effects. However, as we push the boundaries of what's possible, it's also important to recognize the challenges, including the potential environmental and health risks posed by nanoparticles. It is essential that we ensure that these advances are developed with rules to protect both people and planet. Finally, physics and nanotechnology are transforming our world, offering tremendous potential for the future. I encourage all the participants who are engaged with today's speaker, and I hope there will be a fruitful interaction between the participants and guest lecturer, Dr. Vijendra Chaudhary sir, and hope for the future innovation and sustainable physics and material science. Thank you once again.
Okay, thank you, sir, for your guidance to the students and for the faculty. Now, I will introduce the today's chief guest, Honorable Dr. and Captain Vijendra Anand Chaudhary, who is presently working in Dayanand Science College, Latur, as a HOD of the Physics Department. Friends, the sir has a teaching experience of 15 years and he is a research guide in the subject physics. He has guided the many students to get the research degree or the PhD degree. He has delivered his talk in different national and international conferences, and he has published books and articles in many journals, and he has published nearly 5 articles in various journals. They are working as a captain of NCC. That means presently he is on the rank captain of the NCC, National Cadet Corps, and the 4 year experience in synthesis and investigation. The sir has the research experience of about 4 years, and his interest area is ceramic method, chemical deposition, structural characterization of materials. The sir has attended different conferences organized in different universities and institutes, extensive leadership and communication experience through the professional and co-curricular activities. The work with universities and institutes. The sir has the working experience with different universities and institutes such as IIT Powai, Mumbai, Pune University, Solapur University, and RTM Nagpur University. Again, the research interest is solid state, condensed matter physics, ferroelectric ceramic for applications, dielectric and electrical properties of materials, sensor based on thin and thick film devices, synthesis and characterization of PZT, PLT, PLZT, and lead titaniate based on thin film derived by Sol-Gel method, thin films and nanotechnology. These are the research interest area of the sir, awards and honors. The assistant coordinator for motivational bridge course MBC 1st to 26 June 2010 in mathematical methods in physics and laboratory practices for BSc first year and second year students held at Dayanand Science College Latur. Course is in association with Indian Association of Physics Teachers. Again, he is felicitated by a lieutenant rank after a successful completion of army training during 3rd July 2012 to 29 September 2012. Best Pilot Award during the training, the 3rd July to 29 September. A Best Presentation Award in International Conference on Functional Materials and Microwaves. The sir again gets the research award, Bharat Ratna Dr. APJ Abdul Kalam International Honor Award in 2020, Dr. APJ Abdul Kalam Lifetime Achievement Award in 2020, Mahatma Jyotiba Phule International Award in 2021. The sir has given his best contribution in the development of institution, Dayanand Science College Latur. He is presently working as a member of the steering committee of NAC at college, member of internal examination committee, member of youth festival committee, member of discipline committee, worked as a member of cultural and NSS committee, the discipline and supervision committee. Sir, he has given his best efforts in different committees as mentioned. Again, the sir has the interest in the cultural activity and the sports activity. Sir has represented college at university level in athletics. That means the sir is a dynamic and versatile personality which is available today for the guest lecture. I hope the students can be benefited and will be motivated for the research field. Now with this introduction, I request our today's chief guest to deliver his talk, Honorable Captain Dr. Chaudhary sir. Hello sir. Hello.
Yes, sir.
Are you
Am I
getting me
audible,
sir?
sir?
Yes sir. Yes sir.
Yes, sir. Yes. Thanks for my introduction to all the faculty member. Uh, First, I would say thanks to the president of special appearance, Professor M.A. Jogdan sir, uh, Jogade sir, Vice Principal, Major Dr. M.N. Gaikwad sir, convener of this guest lecture, Dr. L.B. Jadhav sir, co-convener Professor N.S. Shinde sir. Thanks for me giving this opportunity to deliver and enlighten your students through the guest lectures. So, may I permission to start the lecture, sir?
Yes, sir. Yes.
So I will share my slide here by using share screen.
Hello.
Yes, sir. Wait,
Uh,
I'm sharing my slide.
Okay.
So my slide is visible to all
Yes,
of you?
sir. Yes, sir.
Okay, sir. So I will start my presentation to the students. So good morning, all of you. I think the student is from BSc and MSc.
Of the UG college course, sir.
Okay. Okay, sir. So it is the presentation will be leads to the BSc student to enroll in particular MSc physics by using the new scenario with the nano hero. So world is particularly uh, glowing with a nanoscience and nanotechnology. So I think it should be definitely helpful for the students. First, if you can see here, there are certain ages, particularly from last era. The first, if you can see that, the first has been started with the Stone Age. If you can see here, there are lots of stone which is used for cutting tools or prepare the any apparatus by using the stone. Then we will have a ceramic age, then copper age, bronze age, then iron, and after that it will start with the silicon age. And nowadays the people are working on the nano ages, which is used in a multidisciplinary approach. in recent area. Basically, Stone Age is started nearly 20, or you can say like before crisis. Then Bronze Age near about 3200 BC. Iron Age started nearly 1200 BC. Concrete Age, particularly, that is started with 200 BC. Steel Age should be started at 1850 AG. Silicon Age will be started at 950. After the Silicon Age, it can be blooming the world, that is the age of miniaturization, and that can be started in 1990s. That age of that generation is called as nano age. What is the major breakthrough during the last 30 years? Particularly, these ages started that the quasicrystals, which can be developed in 1984. Then the study was growing up with high PC oxides supercapacitor, which can be mostly used in various applications. That is started in 1986. Supramolecular chemistry, it was studied at 1987. Then fluorescence and nanotubes, which can be started the development in 1990s. Mesophorous solids, 1992. Or materials like CMR, 1993, and conducting polymers will be started in 2000. Graphene, 2007, and the nanomaterials, which can be started in between that, that is the mid of 1990s. So we can say that the unpredictable boom was witnessed in material chemistry, and which was never seen before. So it has the synthesis and characterization techniques which can be playing a crucial role in the development of nanotechnology. So what ancient history said, nanotechnology is working in new things. We can say that it should be the old thing quoted in the new models. Okay, that is nanomaterials. Like we can say in Vedas, Bhasmas were the first example of nanomaterial. We use Bhasmas particularly. Then Bhasmikaran, that is perhaps we can say that that is also old method which can be prepared the nanomaterials. Then gold, silver is also used in the Ayurvedas, that is not nanocrystalline material. And in Chinese, they have been used a colloidal gold that can be used for the medicine since a last scenario. So what will be happen when the Michael Faraday it has worked on the gold colloids, that is metallic divided state, in 1887. So he has started working on gold colloids and he developed the new related to the nanomaterials. After that, Richard Feynman has made a statement that there is a plenty of room at the bottoms, and that was particularly he has said in 29 December 1959 that it should be a meeting of physical or American Physical Society which can be held at California Institute of Technology. So there are plenty of rooms at the bottoms, means the quantum computing we can heard that he in nanoscience we can say that nanomaterial is nearly it should be in the 1 to 100 nanometers. and its power, it should be considered as 10 to the power minus 9. So on that particularly, he said the statement that there are plenty of rooms at the bottom. In 1980s, the first metal particle was considered, that was discovered by P.P. Edwards. He said that it will be having a divided metals. And in midway in between 1990s, we can say that the nanomaterials become very popular and fashionable because the variation of colors in the material, it should be famous. And we will also say that the nanomaterials will be goes into the a very small size, so the volume ratio can be increased and we can study the further properties of the materials. So in advancement of the nanotechnology, few instrument was developed at that time. So one of that, the instrument that name as AFM, that is atomic force microscopy, that time that was developed to study characteristics of the material. With that, STM was also developed, and the high resolution transmission electrons microscopy is also developed. So this term nanomaterials may be put into the new concept. So we can say that nanomaterials may be new, but not the concept, because nanomaterials can be used from last era with the Ayurvedas. They are using or they are preparing the nanomaterials, but they didn't know these are the nanomaterials. But the recent the scientists has worked so many things on the materials, and they will come to conclusion that it should be a nanomaterials which can be having a smaller in size. So nature has been making a nanomaterial since ages. So that can be particularly seen. So the genesis of nanotechnology, what is that? The term nanotechnology, how it should become. So the term nanotechnology was first used in 1974 by Japanese engineer, that is Norio Taniguchi. He has worked on the STM and TEM, and he has developed the nanotechnology. And the actual beginning, that was with the invention of the STM, that is scanning tunneling microscope, by the German Guard beginning and Heinrich Reher, with the help of these two scientists. So they received the Nobel Prize on this particular invention. It was done in 1986, and he has found this type of representation by using STM and with the TEM in 1986. He has found out the structure like this particularly. After that, the arrangement of atom by atom has to be done, and the name was written by using this atom, that is IBM. So they have used particularly the 35 xenon atom on nickel surface, and they have used the name as IBM. So if you are, they have used the STM particularly, that is scanning tunneling microscope, and they have written as IBM with xenon atom on nickel surface. So we cannot put atom on atom. It is very difficult to go ahead with this, but we are using atom by atom, and they will put this name particularly by using these materials. So it was the invention which can be done by IBM. After that, the genesis of nanoscience and nanotechnology, which can be seen that AFM and that to be the optical tweezers. So AFM is what? Atomic force microscopy. By using this, we can study the material or we can investigate the individual atoms or molecules which will have rise to numerous new possibilities in nanotechnology. So atomic force microscopy, particularly likewise IBM, they have also written nano words that can be created and imagined by using this atomic force microscopy. So the treatment is like this. If they are using the lasers over here and they will put the metal tips on this and they will find out the names on these chips. Okay. And after that, they will study these particular nano words by using this AFM. So if you can see that these two glasses, which is a particular glass, we can say that is a, you can use it for any purpose, but that British Museum has still they have preserved these glasses in their museum at London, so that it should be a 4th century, and that is made up of glass. You can see that there are two type of colors and materials they have used. So after that, the study has been gone, and it can be said that the first glass should be considered as to be the transmitted light, and second should be considered as to be the reflected light. So first, what they have considered that the atom should be a colorless. It should be having the size of 1 angstrom. When the color should be changes, the gold cluster should be always be less than 1 nanometer. So that time you will receive the orange color. Then gold nanoparticle, it should be in the range of 3 to 30 nanometers, and red gold particles can be considered over here. And cosmic and blue color should be considered as per variation of the length. So gold building blocks from the atom to microscopic, and they're changing the colors. So when we will go to the atoms to the macroscopic approach, that time the color will be changes. So this was already done in the 4th century. Now we are just changing this property and finding out the new material for the new applications. So what is nanomaterials? Here I will just show you how millimeter to changes micrometer and move towards the nanoscale. So if you can see that particularly that millimeter to micrometer, there will be no changes in the physical law and effect, particularly when there will be a change in micrometer to nanometers. That time the physical law and the effect of the material will be differs and the properties will be changed. So nanometer dimension is comparable to characteristics length scale of elementary process and is the scale at which nature operates. So if you can see the DNA, virus, protein, etc. So in that, how the size will be changes that I have shown here. So what will be changes in the electronic? There are certain properties like electronic property, physical property, chemical properties, and catalytic properties. So if you can see here, so in the electronic property, so quantum size effect and band gap tailorings should be considered. In physical property, what we have studied, we have to study the microstructure, melting point, hardness, ductility, the ceramic material. And chemical property, we have to study the structure, catalysis, and reactivity of the material. So interface and the surface become very important in this particular material. Now, how to induce the functionality of the material? So it can be depend on the various factors. So what is that factor? The first factor is considered as the structural, then bonding of the material, composition, size, shape, and microstructure. So by using this particular functionality, the properties can be vary with the materials. Now, what is nanoscale? So, BSc student, I think we must know up to the micrometer, but the nanometer is what exactly? Nano means we will say that it should be a means billionth, that is 10 to the power minus 9. Okay, so nanometer is a billionth of a meter. So we can say that 1 nanometer is equal to 10 to the power minus 9 meter. So here I have shown the various sizes of the particular biological and other objects, which is shown here. The first object we can see that we can start with the tennis ball. The size of tennis will be considered as to be the 10 to the power 4. Bacteria will be considered as to be the 10 to the power 3. Viruses and glucose and all these things will be considered as 1. You can see that the various property particularly. So nano devices is what exactly? It should be considered as the nanopores, then nanotubes, quantum dots, which is particularly used in various technology like LG and all. They're using the quantum computing for the structure. Nearly 10 lakh nanometers, which is nearly about 0.1 millimeters. By using this, you can identify the scales. So you can see here, water molecule is 10 to the power minus 1. So how the power of 10 to the power minus 9 is? So how material will be formed into 10 to the power minus 9 meter? If you can see here, the various things, blood cells, then a man which is having 1.62 meters tall or 2 billion nanometers. We can convert it into the meters and nanometers. Again, quantum core shell will be there, and the DNA will be particularly approximately 2 nanometers. Okay, a standard of DNA, particularly 2 nanometers wide. So, variety of things. By using this, we can compare the materials. Okay, so that is a nanotechnology. So nanoscale is particularly you can convert it. 1 nanometer is equal to 10 to the power minus.
Sir, your sound is not able to audible. You are not audible, sir.
That is very important to study. Nanoscience means exactly what? We have to study the smaller or nanostructure. We have to study the nanostructure that are smaller than a fundamental physical properties, like length scale, conventional theory. Okay, and it can be may not no longer to the new phenomena that can be emerges. So in quantum mechanics, effects are very important, that at this scale gravity would become less important, and particularly the surface area, or we can say the surface tension, that is attraction, would be becomes in, you can say, increasingly more sufficient or to the electromagnetic field, and that can be control the behavior of materials. So it is very important to control the behavior. So by using this significance and magnetic electromagnetic field, we have to control the behavior of the materials. So that is the nanoscience. So, so what we have to study in the nanoscience particularly? we have to study the matter on atomic and molecular scale. What we have to study in nanoscience? We have to study the matter on an atomic and molecular scale. So generally, nanotechnology deals with the structure size between 1 nanometer to the 100 nanometers in at least one dimension, and involves developing the materials or device within that size. So when something is reduced, particularly when something is reduced particularly, then you can say that it will change something. So if you can see the different color particularly over here, so what is that different color? So what is changing? So it should be changing its colors, specific properties at large size, and nanoscience studies will be the change in an object and its new properties. So some chemical difference that you can see, if you have a bulk material, then the color should be particularly like this, dark color, maroon color should be shown. Then again, when the size will be into the 23 angstrom, then color is changed. It should be 12 angstrom. Then again the color will be changed. So again, if it should be 7 angstrom, then it should be color will be changes. So it is a CDS, that is cadmium sulfate nanoparticles, which is showing with the different colors as per the size changes. What is the physical approach, particularly in the nanoscience and nanotechnology? We have to see the change in mechanical, optical, magnetic, and electrical, thermodynamical, acoustic properties of the material at nano level. So what you have to study here? You have to study the change in these properties. In chemistry, what we have to study? We have to study the catalytic activity, which is considered as to large surface to volume ratio. Reactivity, rate of reaction, formation of new molecules, supermolecules, and lots of things. In biological, what we have to study, or what biology has the approach? It has the approach of interaction materials to living cells, tissue, and other organisms. So toxicity and antibacterial activity will be considered, or the manipulation of DNA that can be considered of in the biological approach. So the properties of nanomaterials having a particular factors. What are that factors? That factors are to be, which we are considering, that the relatively large surface area in relation to their volume, and it occurs the quantum effect. So what is the reason behind that? क्या reason आहे तर you will require the fine structure and they become more reactive. Then at few nanometers dimension, the quantum effect dominates and the material starts obeying the law of quantum mechanics, which is governed by classical mechanics in bulk material. So this has the major impact on the materials with optical, electrical, and magnetic. So we can classify this particularly by using the nanoscale of 1-dimensional, 2-dimensional, and 3-dimensional. So what is exactly 1-dimensional? Gives you, it should be considered as to the variation in colors particularly, and the dots will be like this. So 1-dimensional nanowires tube, you can see here, graphene plate is also there. Then in 2-dimensional sheet, we can see here there will be a structure of 2-dimensional graphene, particularly which is shown here like this. And we have to, we got the another things. So 1-dimensional, we will get the film, layer, and surface coating that are just 1 to the few atoms or molecule thick. In 2, so if you can see that the nanoparticles of bulk particle. So which are they? It should be Ag, Au, titanium oxide, zinc oxide, okay, which can be used particularly to fix the particle size, okay. And in three-dimensional, you can find out the structure like this. Fluorescence is also considered in particular material in one-dimensional. Then three-dimensional nanoscale, you can see here. Then what about the two-dimensional nano wires? So in that particularly, the carbon nanotubes will be considered and which can be discovered in 1991 by Japanese researchers. Okay, and that his name is Sumio Ijima. It consists of layer of graphite. It is just one atom thick. So which is the rolled up onto the seamless cylinder. If you can see here, I will just move this particular application. It should be like this particularly. Now, so these are the three classification of particular nanomaterials. So if you can see here, the CNTs, that is a single wall, one tube, several concentration tubes, particularly has been to be considered in two-dimensional. In we can also see the inorganic nanotubes in two-dimensional nanoscale. Nanowires is also there. There is the example of this. Nanofibers is also developed in two-dimensional system. Biopolymers also considered. Nanopores. So I will show you how nanometers have superior properties than the bulk substance. There are two type of things. One is nano substance and one is bulk. So the range between 1 to 100 nanometer is nanomaterials, and beyond that we will consider that it should be a bulk materials. Okay. So in nanomaterials have a good strength of mechanical properties. We will have the thermal stability. We will consider the catalytic activity, particularly as per the chemistry is concerned. Then we will also consider the electrical conductivity, which gives you the nanomaterials is superior, or the property of nanomaterials is superior than the bulk substance. Magnetic properties also considered, and optical properties. So in quantum electronics, nonlinear optics, sensing technology, information storage, and processing. Okay, so in solar cell, nowadays solar cell are used to household, in farming, or in agriculture purpose. Super plastic ceramics. So this can be have the most of the application that can be used. New field, if you can think about the new field, so nano fabrications, they are preparing the nano device, and they are preparing the nanobiology and nano catalysis. So we can say that this nanotechnology have a interdisciplinary approach towards the science discipline. So what is nanotechnology? Actually, it should be a word. It should be a technology particularly. So what is that? Nano is small, which is having the range of 1 to 100 nanometers. So technology means it should be developing a technology. So design, production and characterization and application of nanostructure material. So nanostructure material that it can be considered for the size and shape of the materials. So what is nanoscience? As per the UK Royal Society, that is the study of phenomena and manipulation of materials at atomic, molecular and micromolecular scale, where properties differ. की नॅनो सायन्स म्हणजे काय, की एक स्टडी आहे, कशाची आहे, हा एक फेनॉमेना आहे मॅनिप्युलेशन करण्यासाठी. त्याच्यामध्ये आपण काय स्टडी करतो, तर आपण ॲटॉमिक, मॉलिक्युलर किंवा मायक्रो मॉलिक्युलर लेवलला आपण त्याचा अभ्यास करतो आणि त्याची जी प्रॉपर्टी फाइंड आउट करून त्याला लार्ज स्केलला इम्प्लिमेंट करण्याचा प्रयत्न करतो. दॅट इज नॅनो सायन्स. व्हॉट इज नॅनो टेक्नॉलॉजी? नॅनो टेक्नॉलॉजी म्हणजे काय, की आपण डिझाईन करतो, त्याचं कॅरेक्टरायझेशन करतो आणि त्याचं प्रोडक्शन करतो. तर प्रोडक्शन करून काय बघतो आपण, तर वी हॅव टू स्टडी द अप्लिकेशन ऑफ स्ट्रक्चर. त्याचं अप्लिकेशन, त्या स्ट्रक्चरचं अप्लिकेशन काय आहे. आता स्ट्रक्चर जर आपण बघितलं तर क्रिस्टल स्ट्रक्चर जे आहे, जे आपल्याला बीएससी थर्ड इयरला आहे, व्हॉट इज दॅट, देर आर 2 डायमेन्शनल अँड 3 डायमेन्शनल क्रिस्टल स्ट्रक्चर. तर 3 डायमेन्शनल आपण क्रिस्टल स्ट्रक्चर बघितलं, देर आर 7 crystal systems. Okay, so these are particularly, so we have to find out the structure and we can find out that structure will be applicable to which application. So we have to control the shape and size of the at nanometer scale. So त्यासाठी आपण त्याचा स्ट्रक्चर डिफाइन करतो. Nanotechnology. Anybody of you tell me what is the these two pictures shown here? Any students? कोणी सांगू शकतं काय कोणते पिक्चर्स आहेत? Anybody of you? Anyone on unmute and tell me what is these pictures if you know. So I will tell you the approach of nanotechnology. माहिती आहे दोन पिक्चर कशाचे आहेत?
गेटवे ऑफ
आता
इंडिया
एक वाला?
आणि गेटवे ऑफ इंडिया.
व्हेरी गुड, व्हेरी गुड. आणि दुसरं इट इज अ केव्स. ओके, आता यामध्ये आपल्याला काय बघायचं आहे, की हा बनला कसा आहे. नॅनो टेक्नॉलॉजी मध्ये दोन प्रकारचे अप्रोच आहेत, टॉप डाऊन अँड बॉटम अप. किती प्रकारचे अप्रोच आहे? दोन प्रकारचे, वरतून खाली आणि खालून वरपर्यंत. ते मी तुम्हाला सांगतो कसं. सी हियर, टू अप्रोच ऑफ नॅनो टेक्नॉलॉजी, दॅट इज बॉटम अप अँड टॉप डाऊन. So see two different approach here. Here one man is cutting the stone and other will be making, two kids will be making the, we can say that is a building blocks on one. So top down approach is what? Top down approach म्हणजे काय, वरतून खाली जाणे. लेण्या बघा तुम्ही, काही लेण्या अशा आहेत की ज्या वरतून अशा कट केलेल्या आहेत आणि खालपर्यंत डेव्हलप केलेल्या आहेत एखाद्या दगडाला. सो स्टार्टिंग विथ द बल्क मटेरियल अँड कट अवे द मटेरियल टू मेक व्हॉट यू वॉन्ट. आपल्याला काय करायचंय, स्टार्ट करायचं आहे त्या मटेरियलला कटिंगला आणि त्या मटेरियलला कट करून तुम्हाला जे वाटेल ते बनवा. दुसरा अप्रोच काय आहे, बॉटम अप. याच्यामध्ये काय आहे की तुम्ही एक बिल्डिंग ब्लॉक्स बनवत आहेत, व्हॉट यू वॉन्ट, बाय असेंबलिंग इट फ्रॉम बिल्डिंग ब्लॉक्स. सो atom and atom is very difficult to prepare the building block. So such atom and molecules will be considered, and that time we can prepare the atom by atom or molecule by molecules or cluster by cluster. So that is the bottom up approach. So top down and bottom up approach will be considered over here. So how, that I will tell you. So what is the top down approach? So in that top down approach, electron beam lithoscopy can be used for the synthesis of this material. So photonic crystal using EBL, they have used particular this type of approach, and by using the electron beam lithoscopy system, we have to consider that. So IBM is also considering this type of approach. Particularly if you can see, it should be a bottom up approach. खालून त्याची नीप बघा, तुम्ही बघितली असेल याची नीप, तर खालून ब्रॉड आहे आणि वरती टोकदार आहे. सो बॉटम अप अप्रोच आहे IBM चा. Okay, so atom core shells will be there. Now हा दोन प्रकारचे अप्रोच झाल्यानंतर we must have to study the novel properties which is dependent, that is the size dependent and shape dependent. The size dependent मध्ये we have studied the surface plasma resonance that can be studied in the metals. Semiconductor मध्ये आपण काय बघतो, quantum confinement effect बघतो, and all materials मध्ये enhanced surface area आपण consider करतो. So how to synthesis these two approaches, that is top down and bottom up, that I will tell you within a short because it's a research methodology. So I will take the top down techniques manufacturing. Okay, so if you can consider the high energy ball milling, then it can be cut into the planetary boxes, then vibrating it, then high pressures can be used over there, then homogenized and membrane reactors will be shown. It should be differently seen particularly. And in bottom up approach, you can see microbiological process will be scattered particularly, then electrospinning will be there, and then chemical process which will combine together. So these are the two different things which is different with one another. So how we can synthesize this method? The synthesis method is having so many things. There are so many synthesis method. We can say that the ceramic method, that is solid state synthesis, soft chemical synthesis मध्ये तुम्हाला येतात combustion synthesis, template methods, co-precipitation, solvent resistor synthesis, sonochemical, and other synthesis method can be there. So other methods, intercalation, then ion exchange methods, high pressure synthesis, de-intercalations method, vacuum heat treatment will be there, melt and quenching method is there. Melt and quenching method is used to prepare the glass samples particularly. Processing मध्ये इंजेक्ट प्रिंटिंग आहे, स्क्रीनिंग प्रिंटिंग आहे, स्पिन कोटिंग आहे. बायोलॉजिकल रूट्स मध्ये microbes, bacteria or fungi find out करण्यासाठी you can use particular this method. Now soft chemical method is involved with a variety of things. That is, it required the surface area. It should be a fast method. Metastable phases. It has shape controlling this method, size controlling also considered in the soft chemical method, and homogeneity of the samples is also there. So soft chemical method is mostly used nowadays, particularly. Nanomaterials can be used, particularly healthcare, energy conservation, sensors, can be used in cosmetics, environments, potable waters. How we can synthesize the sample? So it is depend particularly on the three phases. One is liquid phase, other is gas phase, and vapor phase. या तीन phases मध्ये आपण synthesis करू शकतो. So what liquid phase involve? कोणत्या कोणत्या मेथड आहे लिक्विड फेज मध्ये? Co-precipitation आहे, salt gel आहे, and microsynthesis and other methods can be involved. Gas phase मध्ये we can use particular method of using solid precursor, then ion sputtering will be there, spark discharge generation will be there. So method can be used in liquid. CVS, that is chemical vapor synthesis, spray pyrolysis, laser pyrolysis, thermal plasma synthesis, that can be used in the gas phase synthesis. Okay, so we can just see one of the method which can be used to synthesize the sample. That method is considered as sol gel method. Okay, so what is sol gel method? Particularly, sol gel method offers a significant advantage such as high purity, chemical homogeneity, and control of particle size. So it has lower processing temperature. त्याला कमी वेळ लागतो बनवायला. It has the variety of advantage to achieve the chemical homogeneity and desired product due to the intimacy of mixing of the material. So sol gel is widely used for preparing the powder and film for use variety of application. आता ते कसं करायचं हे मी तुम्हाला सांगतो. बघा, आपण एक एक्झाम्पल घेऊयात एबीओ3 टाइप मटेरियलचं. ओके, सो काय काय स्टेप्स आपल्याला ते बनवण्यासाठी लागतात ते आपण बघूया. त्याच्यामध्ये आपल्याला पहिल्यांदा काय करावं लागतं की वी हॅव 2 टाइप ऑफ थिंग्स कॉन्स्टिट्युएंट्स, एक ए आहे आणि एक बी आहे. सो आपल्याला दोन कंटेन कॉन्स्टिट्युएंट्सचं क्लिअर सोल्युशन बनवावं लागतं. देन we will have to hydrolysis of solution which can leading to the formation of inorganic polymers and the network by condensation reaction. आणि लास्ट प्रोसेस आहे की तुम्हाला त्याचं जेल मिळतं किंवा पावडर मिळते. सो जेल जर मिळालं तर यू कॅन प्रिपेअर द थिन फिल्म, पावडर जर मिळालं तर यू कॅन यूज इट फॉर द फर्दर कॅरेक्टरायझेशन. सो इट कॅन बी टोटली बेस्ड ऑन द केमिस्ट्री ऑफ alkoxides. So you see here, I will just give you some example of this. PbTiO3, how you have to prepare the PbTiO3. पहिल्यांदा आपल्याला काय करावं लागतं PbTiO3 बनवण्यासाठी. आपल्याला Pb plus this material we have to take, that is easily soluble in the particular liquid or in solute and solvent. So first we have to take the lead acetate, that in ethylene glycol. इथिलीन ग्लायकॉल मध्ये आपण काय घेणार, लीड ऍसिड घेणार आणि नंतर त्याचं फॉर्मेशन करून हायली स्टेबल स्टॅइकोमेट्रिक प्रिकर्सर मध्ये त्याचं सोल्युशन तयार करणार ऍज अ टिटॅनियम आयसोप्रोपॉक्साइड इन असिटिल एसिटोन मध्ये घेऊन. देन सॉल्वंट लाईक ऍसिटाइल एसिटोन आणि इथिलीन ग्लायकॉल आपण घेणार, कारण की तो काय करतो, तो इट शुड बी ऍक्ट ऍज अ डोनर लिजन आणि टिटॅनियम आयसोप्रोपॉक्साइड अँड कंट्रोल देअर हायड्रोलिसिस अँड पॉलिकंडेन्सेशन रिएक्शन. तर आपण जेव्हा इथिलीन ग्लायकॉल आणि ऍसिटोन घेतलं तेव्हा आपल्याला एक्स प्रिकर्सर मिळतं आणि नंतर आपल्याला काय करावं लागतं, टिटॅनियम प्रिकर्सर तयार करावं लागतं. दोन्ही प्रिकर्सर तयार केल्यावर काय करायचं की त्यांना एक्स प्लस वाय दोन्ही मिक्स करायचं, रिफ्लेक्स करायचं आणि टिटॅनियम ऍक्सो लीड टिटॅनेट प्रिकर्सर आपण तयार करायचं. सो झेड मध्ये आपण परत वॉटर इन्व्हॉल्व करणार आणि शेवटी आपण काय बनणार, लीड टिटॅनियम ऑक्साइड आपण तयार करणार. सो दीज आर द सिंपल मेथड बाय युजिंग वी हॅव टू प्रिपेअर द सॅम्पल. नाउ आय विल शो यू द डायग्राम हाऊ वी हॅव टू प्रिपेअर दिस सॅम्पल. पहिल्यांदा आपण काय केलं की वी हॅव टेकन द लीड टिटॅनियम आयसोप्रोपॉक्साइड, त्याच्यामध्ये आपण असिटाइल एसिटोन मिक्स केलं. ओके, मग त्याच्यामध्ये आपण इथिलीन ग्लायकॉल टाकून त्याला रिफ्लेक्स केलं. कितीला केलं, 120 डिग्री सेंटीग्रेडला. किती तास, 1 तास केलं. मग याच्यामध्ये रिफ्लेक्स केल्यानंतर आपण लीड ऍसिटेटचं एक प्रिकर्सर बनवलं, त्याच्यामध्ये इथिलीन ग्लायकॉल टाकलं आणि रिफ्लेक्स केलं 120 डिग्री सेंटीग्रेडला. किती आवरला, 1 आवरला. आणि त्याच्यापासून आपण काय तयार केलं, लीड ऍसिटेट तयार केलं सोल्युशन. मग दोन्ही सोल्युशन मिक्स करून पुन्हा त्याला आपण रिफ्लेक्स केलं. रिफ्लेक्स केलं म्हणजे काय केलं, त्याला मॅग्नेटिक स्टररवर ठेवून त्याला 120 डिग्रीला 4 घंटे स्टरर केलं. ओके, केमिस्ट्री स्टुडंट नो दिस प्रोसेस. नंतर त्याच्यामध्ये डीआयोनाइज वॉटर टाकलं. When we put the deionized water, then that time we will have the lead titanate gel. तेव्हा आपल्याला काय मिळेल, लीड टिटॅनेट जेल मिळेल. मग आपण ह्या लीड टिटॅनेट जेलला आपण स्पिन करायचं स्पिन कोटरच्या साह्याने. देन तुमची फिल्म तयार होईल आणि या जेलला जर आपण ड्राय केलं तर तुम्हाला काय मिळेल, तुम्हाला त्याची पावडर मिळेल. सो बाय युजिंग दिस मेथड यू कॅन गेट फिल्म अँड पावडर्स. These are one of the method. By using this, we can prepare the nanoparticles. So spin coater अशा प्रकारचं असतं. If you can see this diagram, you can easily understood. Spinner is here. Glass substrate मध्ये आपण ते सगळं सोल्युशन तयार केलंय, मिक्स केलं आणि त्या ग्लास सबस्ट्रेट वर टाकलं की ती ग्लास सबस्ट्रेट मध्ये आपल्याला त्याची फिल्म मिळते. सो अशा प्रकारे आपण सॉल्ट जेलनी सॅम्पल तयार करू शकतो. मग याचा यूज आपण कॅरेक्टरायझेशन साठी करायचं आणि फर्दर स्टडी करायचं की आपण याचा उपयोग कुठे करणार आहोत, कोणत्या मटेरियल ऍप्लिकेशन साठी आपण याचा करणार आहोत, सुपर कॅपॅसिटर मध्ये वापरणार आहोत का अजून कोणत्या मटेरियल मध्ये वापरणार आहोत की ज्याची आपल्याला प्रॉपर्टी स्टडी करता येईल. So salt gel precursors method will be like this. Particularly precursor आहे, सोल्युशन मिळतं, जेल तयार होतं, मग एरोजेल मध्ये जाते कन्वर्जन, देन परत स्ट्रिपिंग ड्रॉपलेट्स मध्ये होतं, मग इथे फिल्म मिळते आणि इकडे त्याला पावडर मिळते. सो वी कॅन यूज इट फॉर जेल, फॉर डेन्स सिरामिक अँड थिन फिल्म. So another method is spray pyrolysis. I will not go much in detail spray pyrolysis. मी फंडामेंटल काही गोष्टी तुम्हाला सांगेल याच्यामध्ये. सो दीज आर द युनिट ऑफ स्प्रे पॅरालिसिस. सेम सॉल्जर मेथड सारखं स्प्रे पॅरालिसिस एक युनिट आहे. यामध्ये आपण सॅम्पल तयार करतो. स्प्रे पॅरालिसिस युनिट कसं बनतं हे मी तुम्हाला पहिल्यांदा सांगेल. तर आपल्याला एक कंप्रेसर घ्यावं लागतं, एअर कंप्रेसर, ज्यामध्ये हा कंटेनर मध्ये आउटलेट एक ठेवावा लागतो. पॉवर सॅम्पल आपण खाली घेतो, म्हणजे तिथे आपण एक हॉट प्लेट लावतो, त्याच्यावर ग्लास सबस्ट्रेट ठेवतो, आणि हा जो नोझल स्प्रे आहे वरती, हा नोझल स्प्रे, या नोझल स्प्रे मधून ते आपण जे काही सोल्युशन तयार केलं आहे ते इथून स्प्रे केलं जातं, आणि हे स्प्रे करून आपण ते सॅम्पल थिन फिल्म तयार करू शकतो. सो दिस टाइप ऑफ थिन फिल्म कॅन बी प्रिपेअर्ड particularly by using the spray paralysis. So it is also one of the simplest method to prepare the sample. याचे यूज काय, याचे पॅरामीटर्स काय आहे, तर याला काय लागतं, सबस्ट्रेट टेम्परेचर लागतं, नेचर ऑफ सबस्ट्रेट लागतात, एअर फ्लो रेट लागतो, नोझल लागतात, and volume of spray solution सुद्धा केलं जातं. प्रिपरेशन ऑफ मेथड सेम, आपल्याला कंपाऊंड घेऊन त्याला प्रिपेअर करता येतं. ZMO preparation of sample will be shown here. Advanced about the techniques, ही टेक्निक का आपण घेतो, तर ही फार कमी पैशामध्ये तयार केली जाते सॅम्पल. दॅट इज मोस्ट इकॉनॉमिकल. नो सोफिस्टिकेटेड इन्स्ट्रुमेंटेशन विल बी देअर. इझी सेटअप आहे. स्टॉकियोमेट्रिक फिल्म तिथे आपल्याला मिळते. लार्ज स्केलवर आपण याचं डिपॉझिशन करू शकतो. पॅरामीटर ऑप्टिमायझेशन इझिली होतात. लो टेम्परेचर टेक्निक्स आहे, याला काही जास्त टेम्परेचर आपल्याला लागत नाही. एनी सबस्ट्रेट कॅन बी प्रिपेअर्ड. यू कॅन टेक इट, ग्लास घेऊ शकतात, अजून टंगस्टन फिलामेंट घेऊ शकतात, किंवा अजून तुम्ही दुसरं घेऊन सबस्ट्रेट घेऊन तुम्ही वापरू शकता. सबस्ट्रेट म्हणजे काय, तर एक ग्लासची पट्टी म्हणजे सबस्ट्रेट. ओके, त्याला व्हॅक्यूमची गरज पडत नाही. सो दीज आर द मोस्ट इम्पॉर्टंट युजफुल टेक्निक टू प्रिपरेशन ऑफ द सॅम्पल्स. नाउ I will show you something that's very important. If you can see that नॅनो काय आहे, कटिंग एज आहे कोलायडल ड्रग्स डिलिव्हरीसाठी. सो नॅनो ड्रग्स डिलिव्हरी ऑल्सो डेव्हलप. कोलायडल गोल्ड कशासाठी वापरतोय, तर नॅनो गोल्ड पार्टिकल्स साठी. सो नॅनो वर्ड्स कम्स इनटू द फार्मास्युटिकल्स ऑल्सो. नॅनो वर्ड कम इनटू द कोलायडल गोल्ड ऑल्सो, कोलायडल ड्रग्स डिलिव्हरी ऑल्सो. सो in 2012 there was 43 approved nano pharmaceutics was there. 43 development of 10 drugs took place before 2000. Out of 43, R&D 22 drugs was invented long before 2000. Remaining drugs do not use specific nano dependent functionality because of some their particular reason, whatever it is. So this can be old drugs into the new clothings. हे जुने जे ड्रग्स आहेत आपण नवीन क्लॉथिंग मध्ये कट डेव्हलप करतोय, म्हणजे ती नॅनो टेक्नॉलॉजी झाली आहे. कारण की एन्शियंट नॅनो टेक्नॉलॉजी कॅन बी यूज फ्रॉम द एन्शियंट हिस्ट्री. सो इट कॅन बी याचे ऍप्लिकेशन जे आहेत ते खूप मोठ्या प्रमाणावर आहे. त्याचं ऍप्लिकेशन आहे मेडिसिन मध्ये, केमिस्ट्री मध्ये, एनर्जी मध्ये, इन्फॉर्मेशन अँड कम्युनिकेशन मध्ये, अदर युजेस मध्ये, फूड प्रिझर्वेशन मध्ये आहे, हाऊस होल्ड यूज आहे, ऑप्टिकल मध्ये आहे, टेक्सटाइल्स मध्ये आहे, गॅस सेन्सिंग आहे. So if you can see here, so variety of applications can be used. Broadly, I will say that nanoparticles will be used in textiles. Textiles म्हणजे आपण कपड्या मार्केट मध्ये you are using a variety of different color and a different variety of dresses. So textiles can be used. The particular development of nanotechnology biomedicals मध्ये वापरलं जात आहे, हेल्थ केअर मध्ये वापरलं जात आहे, फूड ऍग्रिकल्चर मध्ये वापरले जाते, इंडस्ट्रीमध्ये वापरली जाते, इलेक्ट्रॉनिक्स, इन्व्हायरमेंट, रिन्युएबल एनर्जी म्हणजे सोलार एनर्जी. आता आपण सध्या मोस्ट ऑफ द सगळीकडे बघतोय की सोलार एनर्जी लागतात. नवीन गाड्या आल्यात मार्केटमध्ये, इलेक्ट्रॉनिक्स व्हेकल विल बी कम, सो दॅट इलेक्ट्रॉनिक्स व्हेकल विल बी ऑल्सो चार्ज ऑन द रिन्युएबल एनर्जी. सो नॅनो पार्टिकल्स विल बी डेव्हलपिंग व्हरायटी ऑफ रोल्स in the new generation or new era. So it should be lots of applications. So students have a chance in physics to develop their career, particularly in the physics, and they will involve with the you can say, or they will have a hands to develop our nations with the nanoscience and nanotechnology. So meeting energy needs मध्ये आपण काय करू शकतो, मोर इफिशियंट लाइटनिंग आपण करू शकतो, हायड्रोजन बेस्ड एनर्जी तयार करू शकतो, सोलार एनर्जी मध्ये काम करू शकतो, locally distributed power generation मध्ये आपण वर्कआउट करू शकतो. So if you can see here, LEDs can be also particular things. Solar energy can be flexible, ही आपण ते वापरू शकतो. हायड्रोजन बेस्ड एनर्जी मध्ये आपण जाऊ शकतो. So क्लिअर वॉटर सोल्युशन मध्ये सुद्धा इट कॅन बी हॅव्हिंग अ लॉट्स ऑफ अप्लिकेशन. हेल्थ केअर मध्ये एवढे आहेत. दॅन प्रोटेक्टिंग अँड एन्व्हायरमेंट मध्ये लो एनर्जी नीड्स ड्यू टू द लाईट वेट, स्ट्रॉंग मटेरियल, नॅनो कोटिंग, harass cleaning, chemical do not require to be for the further things. So you can see here, so variety of applications can be shown here. I will show you the one picture that you can see that की और तुम्ही मला सांगायचंय की where these people are using the nano science and nanotechnology. तुम्हाला जर लक्षात येईल, सांगता येईल तुम्हाला कोणाला की या पिक्चर मध्ये कुठे कुठे नॅनो सायन्स आणि नॅनो टेक्नॉलॉजीचा वापर होतोय? Anybody of you?
Yes,
हे सांगता येईल?
mobile.
Yes, मोबाईल. अजून
In
लॅपटॉप आहे, गॉगल्स
laptop
आहेत,
also.
कॅमेरा आहे. Okay, so I will show you the next slide. You can see there. So you can see the slide. So you can see here LEDs particularly, then intelligent credit card system मध्ये आहे, extract time via satellite मध्ये आहे, artificial lenses मध्ये आहे, microprocessor मध्ये आहे. So lots of things can be developed by using the fundamental materials of the nanoscience and nanotechnology. So variety of things can be used everywhere nowadays. So few things, again I would like to say that in nanotechnology in food also we are using, particularly dietary supplement must the nanoscience material can be used. Some B12s and mesosilvers will be used in that nanotechnology also used. Medicines part of this. फूड्स मध्ये बघा, पॅकिंग मध्ये आपण मायक्रोब्स मध्ये आपण ते वापरू शकतो. दॅन फूड कंटेनर आहे, सेन्सर वापरून आपण बॅक्टेरिया ऍक्टिव्हिटी मेजर करू शकतो. इफ यू कॅन सी हियर, सो कॉस्मेटिक्स मध्ये सुद्धा विटॅमिन ई, लो बायोटॉक्सिसिटी साठी आपण नॅनो मटेरियल्स वापरू शकतो. सो इट्स फॉर न्यू जनरेशन फॉर द पर्टिक्युलर लेडी. स्किन इम्प्रुव्हमेंट साठी सुद्धा आपल्याला वापरता येतं. यू कॅन से लिपस्टिक्स, मेकअप किट्स, याच्यामध्ये सुद्धा नॅनो सायन्स has developed lots of things, particularly to have a student have a chance to develop their work, particularly by using preparing the natural beauty of the material. So they are using particular titanium dioxide or zinc oxide nanoparticles for the skin purpose. Everybody know this lady Aishwarya Rai. They are also using the sunscreen lotion. You know that UV visible ultrafine rays, which can require the material having band gap, which is absorb only UV light and not the visual. Okay, so in that skin protection, lots of things can be used. So what is the benefit and risk? Life living medical robots, network computers for everyone in world, trillions of dollars of abdomens, repair invention of wondrous products. What is the risk is there? Untraceable weapons of mass destruction. Network cameras so governed can watch over every move. A viscous scramble to own everything. Weapon development fast enough to destabilize any arm race. So these are the pros and cons of the nanoscience. If you can see this peacock, it's a natural beauty. It's having the different colors. So it has materials, electrochromic materials, thermochromic materials. So God has given the nanomaterials. Before that, the people are working on it. So 10 years, 2.6 trillion dollars in industry which is working and involved in the nanoscience and nanotechnology. 2 million jobs at the levels particular of this. The latest improvement and the industry is should be development in energy, healthcare, chemical materials, and nano device. So nanotechnology is a disruptive technology that it can be used everywhere. So countries that acquires the most value from nanotechnology will become the economic superpower. Here, I will conclude that you understand the basic concept of nanoscience and nanotechnology, which can start with the ancient history, and now it is blowing up the world. Thank you.
Thank you, sir.
Hello, thank you, sir. Thank you very much. You have covered the very much vast area of the nanotechnology, ancient history of nanomaterials to the current era. You have given the information regarding to the preparation of the nanomaterials, their wide applications of the nanomaterials, classification of nanomaterials. These informations you have given to our students very lucidly. The lecture was quite informative, impactful, and interesting. I hope this your lecture will be beneficial to our students in the future career, in making their career in the research field. Definitely this information will be helpful to them. Now, I request my colleague, dear colleague, Mr. N.S. Shinde sir, to express his vote of thanks. Shinde sir.
Good afternoon, everyone. On behalf of the Department of Physics, I would like to extend my heartfelt thanks to Dr. Vijendra Anand Chaudhary sir for delivering on an enlightening talk on recent advancement in material science and nanotechnology. Your insights were truly inspiring to our students and the colleagues. A big thank you to our principal, Dr. G.K. Kakre sir, and our special guest, Dr. M.A. Zogre sir, and Major Dr. M.N. Gaikwad sir for their support and encouragement. I also want to thank Dr. L.B. Jadwar sir for organizing this event successfully. Lastly, thank you all students and colleagues for your participations and attentions. Have a great day ahead. Thank you, sir. Jadwar, sir.
Thank you, sir.